Day 513 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 976, largest perimeter triangle. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given an integer array nums, return the largest perimeter of a triangle with a non-zero area formed from the three sides of these lengths. If it is impossible to form any triangle of a non-zero array area, return 0. All right, y'all, so that sounds pretty simple, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, before we get into example 1, I want to go over what we need to check to make sure a triangle is valid. So for a triangle to be valid, all three of these must be true. So A plus B must be greater than C. A plus C must be greater than B, and B plus C must be greater than A, right? And so when I say A plus B, I mean the side. So side A plus side B must be greater than side C, and side A plus side C must be greater than side B, and side B plus side C must be greater than side A. So if all of these are true, then we know we have a valid triangle. Now that we know what forms or what it takes to form a valid triangle, let's take a look at example 1. So in example 1, we have our input nums equals an array of integers 2, 1, and 2. The output is 5. Explanation says you can form a triangle with the side lengths 1, 2, and 2. So just to break this down one step further, we need to see what we want to find the largest perimeter, right? So to do that, we just add up all sides of the triangle, right? So since this only gives us 3 elements, those 3 elements represent the 3 sides. So when you do 2 plus 1, that gives us 3, and 3 plus 2 is going to give us 5. That's how we got 5. And you can see that these 3 elements fit these requirements over here, right? If we do these 2 sides, 2 plus 1 gives us 3, which is greater than 2. If we do these 2 sides right here, 1 plus 2 equals 3, which is greater than 2. And when we do these sides, 2 plus 2 equals 4, which is greater than 1. So all 3 of these rules hold true, so we know we have a valid triangle. And that's why when we add all the sides together, we get 5, and that's how our output is 5. Now, let's take a look at example 2 where they may try to throw a trick question our way where we're not even able to form a valid triangle. So in example 2, we have our input nums equals an array of integers 1, 2, 1, and 10. Our output is 0. Explanation says you cannot use the sides 1, 1, and 2 to form a triangle. Why? Because 1 plus 1 is equal to 2. It's not greater than 2. And remember, we need all of these to hold true. So if just 1 doesn't hold true, then the whole triangle is messed up. And in this case, 1 plus 1 is equal to 2. It's not greater, so that doesn't form a triangle. Then we cannot use the sides length 1, 1, and 10 to form a triangle because 1 plus 1 is less than 10. And we cannot use the sides 1, 2, and 10 to form a triangle because 1 plus 2 is less than 10. Therefore, as we cannot use any 3 side lengths to form a triangle of a non-zero area, we return 0. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Y'all, solution is not that difficult. Now, the first thing we want to do is we want to sort the input array in ascending order so we can easily check the largest possible triangle sides from the end. So for that, we'll just come right here, declare a variable, call it R, and set that equal to nums.sorted, just like this. Boom. Now we need a variable to keep track of the largest valid perimeter found by coming right here, declare a variable called P, and setting that equal to 0. Boom. Now we need to iterate backwards from the last index towards the start. So we're going to say for I in stride, open up the parentheses, from R dot count -1, comma, through 0, comma, by colon -1. So this is going to let us step by -1 each time. So once again, we're going to iterate backwards. Then we're going to come right here and we're going to say where I minus 2 is greater than or equal to 0. Boom. And then this condition right here, I minus 2 is greater than or equal to 0, ensures that we have at least 3 sides to form a triangle at each step. Then we're going to come right here inside the for loop, and we need the sum of the 2 smaller sides in the current triplet. So remember, it's sorted. So to get the 2 smaller sides, we're going to say let num equal r square bracket I minus 1 plus r square bracket I minus 2. Boom. Then we're going to come underneath that, and the largest side, and we're going to get the largest side in the current triple by saying let cur equal r square bracket I. So these are going to be the 2 smaller sides, and this is going to be the largest side. Boom. Then we're going to check the triangle inequality, right? Which what we went over earlier, which is the a plus b is greater than c, and a plus c is greater than b, and b plus c is greater than a. We're going to check that by saying if num is greater than cur, then we're going to open up the brackets, and if it's valid, then we need to update p with the maximum parameter that we found so far by saying p equals max, open up the parentheses, p, comma, num plus cur. Then we'll come right here and say else. Otherwise, we can just continue to the next set of sides by saying continue. Boom. Now we just need to return the largest parameter of any valid triangle that we found by coming right here, and we could just say return P, y'all. That's all she wrote. That's all the code. Let's give it a run before we submit it. Make sure it runs correctly. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 4 milliseconds beats 81.82% of users, y'all. That's what I'm talking about. That's what I like to see, y'all. So with that being said, make sure you get one more look at the code, read it, learn it, love it. And yeah, y'all, I'll see y'all here tomorrow for another day, another LeetCode problem. See y'all then.